Today we're going to graph equations using slope-intercept form. Let's take a look at slope-intercept form. It's y is equal to mx plus b, where m stands for the slope and b is the y-intercept. So if I look at my first example, I have y is equal to negative 4x minus 2. So the slope in this case is the coefficient before x, which is right here. So that is negative 4. If I'm looking at my y-intercept, that is the constant, the number at the end, which is negative 2. Let's place the following equations in slope-intercept form. So again, I want to get y by itself. So there's my wall. The first thing I need to do is I need to isolate that variable. So I'm going to subtract 7x from either side. I have negative 3y is equal to negative 7x plus 9. I'm going to divide both sides by negative 3. And I have y is equal to now negative 7 over negative 3 gives me positive 7 over 3x minus 3. So the slope is 7/3, and the y-intercept is negative 3. Now notice with the slope, we're going to leave that as an improper fraction. With slope, we don't use decimals and we don't use mixed numbers. And looking at number 2, it says negative 1/3 y minus 4x is equal to 6. I'm going to draw my wall. I'm going to isolate my variables, so I'm going to add 4x to either side. Again, I'm trying to get y by itself, so I have it in slope-intercept form. I have the negative 1/3 y is equal to 4x plus 6. Now again, I don't want negative 1/3 y, I just want y. So I'm going to have to get rid of that negative 1/3. How do I do that? I multiply that by the reciprocal, which is negative 3 over 1, or negative 3. But I have to do that throughout the entire equation. So negative 3 over 1 times negative 1 over 3 is y is equal to negative 3 times 4x. So I have to multiply, again, everything by negative 3, so that gives me negative 12x. And then negative 3 times 6 gives me negative 18. So my final answer in slope-intercept form is y is equal to negative 12x minus 18. Let's take a look at a word problem. Snow fell for 9 hours at a rate of 1/2 inch per hour. Before the snowstorm began, there was already 2 inches of snow on the ground. And the statement that we're trying to answer is write an equation that models the situation. So let's go back and see what we have. It fell for 9 hours. There was a rate of 1/2 inch per hour. And there was already 2 inches of snow on the ground before the snowstorm began. So let's look at our slope-intercept form. Y is equal to mx plus b. And we notice that our rate of change is 1/2 inch per hour. So what that means is for every hour, there was 1/2 inch of more snow on the ground. That's the rate that it's changing. So that becomes my coefficient. That's m. That's my slope. My rate of change is 1/2. There's my x. Now, my b is my y-intercept. That's always my starting point. So before the snowstorm started, there were 2 inches of snow on the ground. So it's going to be plus 2. So y is equal to 1/2 x plus 2 is my equation in slope-intercept form that matches that situation. Now we're going to graph using slope-intercept form. So my first example here in blue is y is equal to negative 3x plus 3. So before I get started, I want to identify the parts of the equation that I'm going to need. So the y-intercept is positive 3, right there is my y-intercept. And my slope is negative 3. Now if it helps you, negative 3 is negative 3 over 1, so that might help me when I'm graphing it using my slope. So remember, my y-intercept is my starting point. So I'm going to go up on my y-axis 1, 2, 3, so that's my first point. And my slope is negative 3 over 1. Now remember, if my numerator is negative, that means I'm going to go down. And if my denominator is positive, I'm going to go to the right. So I'm going to go down to the right. So let's count. Again, we're counting from the, I'm not going to the origin. I'm going right from the y-intercept. So I go down 3, 1, 2, 3, and I go to the right 1. I like to go at least one more point. So down 1, 2, 3 to the right 1. Now from here I'm going to graph my line, go through my points, arrows on the end, since a line is consistent and goes on in either direction. Looking at our next equation, we have y is equal to x. Now I don't have a constant there on the end, right? I'm missing one. So that just means that my y-intercept is 0. So I'm going to actually start on the origin. And my slope is my coefficient, my number before x, which there is not one there. We just assume when it says x, it's 1x. So my slope is really 1, and if it helps you, it's 1 over 1. So I'm going to start at my y-intercept, which is 0. right there. And again, because my numerator is positive, I'm going to go up 1. And since my denominator is positive, I'm also going to go to the right one. So again, I go back to my y-intercept, and I go up 1 to the right 1, up 1 to the right 1. If I want to go in the other direction, down 1 to the left 1 is still a positive 1, right? If I have negative 1 over negative 1, that still equals positive 1, which is my slope. So I can go down 1 to the left 1, down 1 to the left 1. And I draw my line through my points, arrows on the end, and that is the graph of my line. Looking at my next equation, I have x is equal to 3. This looks a little different. I don't have a y there, so I have to remember, is this a vertical line or a horizontal line? I'm going to use my Vux Hoy, right? I have an x, so it looks like I'm using my Vux, so the V stands for a vertical line, and I have an undefined slope. So x equals 3, so what that means is I'm going to find 3 on my x-axis, and I'm going to draw a line through that. Just going to make a vertical line all the way through. Anywhere I see x is equal to 3, then I'm going to have a point that is part of that line. My last one is y is equal to negative 4. Again, if I remember that Vux Hoy, my y is my y-intercept, so I know I need a horizontal line because of that h. So I find negative 4 in my graph, which is right here, and I'm going to draw a horizontal line through there, because this is an equation of the line y is equal to negative 4. Everywhere in that line, that y value has a value of negative 4.